Hello everyone. We are from Reuse Oriented Development Team. Today we're gonna explain about ROD or Reuse Oriented Development. So my name is Feril.
My name is Evan.
My name is Hidun.
So let's just get started with it. The things that we will be covering is that what is reuse oriented development, and we will show the diagram showing how reuse oriented development and how it works, the type of software component that used in ROD and its advantages and disadvantages. So first of all, what exactly is ROD? ROD is where they reuse programming or software designs in previous projects. The main idea behind this concept is to reuse software to build higher quality software and to make it better and answer the needs of demand. So here's the ROD diagram. The first one is requirement specification. The next one is component analysis. The next one is require modification. The next one is system design with reuse. The next one is development and integration. And finally, we have the system validation. So what is component analysis? Given the requirement specification, a search is made for components to implement that specification. Usually, there is no exact match and the component that may be used only provides some of the functionality required. What is requirement modification? Requirements are modified to reflect the variable components. Where modifications are possible, the component analysis activity may be re-entered to search for alternative solutions. And the next one is system design with reuse. During this phase, the framework of the system is designed or an existing framework is reused. Some new software may have to be designed if reusable components are not available. And the next one is development and integration. Software that cannot be externally procured is developed, and the component and the COTS systems are integrated to create the new system. System integration is part of the development process rather than the separate activity.
And now moving on to the types of software component used in a reuse-oriented process. First, there are web services that are developed according to service standards which are available for remote invocation. Secondly, we have collections of objects that are developed as a package to be integrated with a component framework, such as .NET or J2EE, with some other frameworks such as libgdx that's for gaming. But in this case, we have .NET, which is a package for C Sharp, Microsoft. But there's also Mono, which is an open source version of .NET for C Sharp. And third, we have standalone software for independent systems that are configured for use in a particular environment. One notable example of the reuse-oriented doctrine is the usage of game engines. So here we have Godot, Unreal, and Unity. They are all game engines. Essentially, what they do is they allow games to be built around them, essentially. Historically, the first video games were created from scratch in order to be compatible with the hardware. This was only viable when video games were simple and only ran on basic graphics, like Tetris, for example, which could be played on a text terminal. Developing games from scratch started becoming a problem when games were being rendered in 3D. Three-dimensional graphics are complicated and require a very talented and dedicated team of developers who specialize in such a field. Thus, creating a graphical framework for every game you develop is not feasible. ID Software thought it would be better to reuse the functionalities available in the game Quake in order to develop future games, such as Quake 2, forming a stripped-down version of Quake. This form of Quake could be reused or even sold off to developers who are planning on developing games for their own companies. This is essentially a very simple form of game engine.
The advantage of ROD. First one, the reuse-oriented model can reduce the overall cost of software development compared with more tedious manual methods. Second one, it can also save time because each phase of the process builds on the previous phase which has already been defined. When carefully carried out, ROD can minimize the likelihood of errors or bugs making their way into the final product. Requirements are known because the analyzer is using a previous software. Disadvantage of ROD. The reuse reuse-oriented development is not always practical in its pure form because a full repertoire of reusable components may not be available. In such instance, some new program components must be designed. If not fully done, ROD can lead to compromise in impressive requirements, resulting in a product that does not fully meet the needs of its intended users. Sometimes using old system component that is not compatible with new version of component. This may lead to an impact on system evolution. The conclusion, the ROD is a staple in the field of software development. With the complexity of software in today's age, it is unfeasible and expensive to engineer a large program from the bottom up without reusing basic components and functions. This method is most notable in game development, where designing a well-rounded graphics library and the means for basic functions, such as controls and sound systems, will take large amounts of time and talent.
So that's all for our reuse-oriented development presentation. I hope you enjoy watching it. Thank you very much. See you next time.